So today we're in section 9.7, the tangent ratio. So we're starting our first lesson of 2 on trig ratios. We're actually going to learn all 3, sine, cosine, and tangent. But for today, we're only doing tangent, right? This is kind of meant to be a warm-up so we can get used to what are we looking at, how do we read these right triangles, and that type of thing. All right, so you might want to pause it on the screen to make sure you get everything down, because I'm just going to go through the acronym with you. All right, but we're going to learn the acronym SOHCAHTOA. This acronym helps us remember which sides get compared with what trig ratio. So for sine, I'm going to compare the opposite side to the hypotenuse. You say of what? Well, it's going to give me an angle measure, and I have to choose the opposite side to that angle and the hypotenuse. Well, hypotenuse is always going to be the same side. It's opposite the right angle. Cosine is adjacent in hypotenuse, and tangent is opposite and adjacent. So if you haven't written this down, this fraction set and the acronym are very important, okay? And that helps you remember how sine, cosine, and tangent are going to work. All right, so the way it looks in example 1, all right, it gives me a triangle, all right, and this triangle has 3 angle measures. So angle R, or the 90-degree angle, will never be the angle that we are measuring, okay? So the 90-degree angle is out. On your homework, it words it, find the measure of the 2 acute angles. Actually, it's going to say find the tangent of the 2 acute angles. What's an acute angle? This is kind of a review. What does it mean for an angle to be acute? A-C-U-T-E, acute. It's less than 90 degrees. So just kind of eyeballing it, I can tell that what angles are less than 90 degrees. No, angles, not side lengths. Which angles? I've already highlighted them yellow. Obviously, R is not an acute angle, but P and Q are. So what I'm going to do is I'm going to find tangent of P and tangent of Q. All right? And the reason being is it's because these are both acute angles, and the directions say find the tangent of the acute angles in the triangle. All right? Well, what was my ratio again? What's my ratio for tangent? What is it? What did we write down? What's my ratio for tangent? Opposite over adjacent. And again, just for today's lesson, this is the only ratio that we're going to learn. All right? So what I need to figure out is what is the side value of the opposite side to angle P. All right? So you see angle P, so you look at the side opposite to angle P, and what's that value? 77. Now you need to look at the adjacent side. And remember what we said. The adjacent side, well, P has 2 adjacent sides, but one of them is the hypotenuse. Okay? The hypotenuse cannot be adjacent also. It's just the hypotenuse. So this one is out. That's the hypotenuse. So the only other side I have that connects is 36. Do you see that? All right, so it's 77 over 36. But I need to double check and just make sure that this answer is in simplest form. So go ahead and just test it in your calculator, 77 over 36, just to make sure it's completely simplified. All right, is it? Okay, yes it is. All right, now I want you to solve for tangent Q the same way. All right, so plug your values into the ratio. So now you're focusing on Q. Which one is opposite, which one's adjacent, put it into a fraction and make sure it's reduced. All right, and remember with tangent, the hypotenuse is not in your ratio. Again, I'm choosing opposite over adjacent, so the opposite side value is 36, and the adjacent is 77. So it's 36 over 77. We know it's fully reduced. There was no common factors. And so that's it, okay? So really there's no math to do except just identifying, okay, here's the angle that I'm solving for. So I'm going opposite and adjacent to that angle. All right, any questions on example 1? right, so you're going to love example 2 because what is the title of the slide?
Using a calculator.
Using a calculator. So get your calculators out. We're going to learn how to use our calculators to find degree measures of angles. On the third row of buttons below the circle button, on the right side, do you see in white it says sine, cosine, tangent, the abbreviations in white? Okay, so those are my buttons that I'm going to focus on. So since today we're learning tangent and it's calling for tangent of 18, we're going to hit the tan button and enter 18 and press equals. Okay, tan 18 and press equal. All right, so it's going to give us a really long decimal, and most of the time our decimal is going to be very, very long. So my rule is that I need to round to 4 decimal places. Well, if I'm rounding to 4 decimal places, I need to know what the 5th digit is. So if you need to, if you make a mistake, it's going to be that you forgot to round. So if your 5th digit, in this case, is a 1, what is that going to do to your 9? Does it leave it the same or raise it up? It just leaves it the same, but you have to look at the 5th digit. If all you do is write the first 4 digits, you might get the answer wrong if you were supposed to round it up, okay? So you don't have to write that step down. You can just look in your calculator, but I wrote it down so you can see that, all right? What I need to see is your answer out 4 decimal places. Now, why did I write the approximation symbol instead of the equal symbol? Okay, because I rounded my answer. My calculator gave me a much longer decimal, and honestly, it keeps going even past that. Okay, so I wrote that symbol because I actually rounded my answer. All right, go ahead and solve for the next one, tangent of 45. Very rarely would this happen, but tangent 45 is going to actually be 1. Okay? Like I said, very rarely. All right, let's go ahead and do tangent 39 and make sure you round to 4 decimal places. All right, so it's going to be 0.8097. What's my 5th digit?
8.
An 8. So this is a prime example of if you forget to go to that 5th digit, your answer is going to be wrong. If you just write 0.8097 and ignore that 5th digit, you're not going to realize that you're actually supposed to round it, okay? 8098. 8098. Who got that? 8098? Okay. All right, so that's example 2. Now, example 3 is a combination of both example 1 and 2. Before we do the word problem, I want to just do one that's more like your homework. The word problems are important, and I want to get to it, but sometimes when the first problem you see is a word problem, would you agree? It's kind of hard to understand the concept because you're also trying to understand the word problem. All right, so let's just do one of the shapes first. Let me find one that would work. Okay, so let's say we have a triangle that looks like this. And it'd probably be helpful if you would just sketch the triangle real quick in your notes. Okay, the right angle is always going to be marked. That's going to be really helpful. And then we have an angle measure of 63 degrees, 10, and x. All right, so let's pretend for a minute that our lesson is not just tangent, because I know that I'm solving for tangent because the lesson is tangent. But what if I didn't know that? How could I figure out from this information that I'm solving for tangent? Here's how you do it. You have an angle measure. This is always your starting point. Now, from that angle, which sides do you know? 10 is 10 adjacent, hypotenuse, or opposite, and is x adjacent, hypotenuse, or opposite? Just think to yourself for a minute. What is 10 and what is x? All right? Okay. Well, let's talk first about what it's not. Here's the right angle That's the hypotenuse. So 10 and x are not the hypotenuse. Do you understand that? Okay. So now all we have left is opposite and adjacent. So x is which side? Opposite or adjacent? It's opposite, and then 10 is adjacent. So which trig ratio have we learned that has opposite and adjacent in the ratio? Tangent. So that's how I know it's tangent. You see that? So now I'm going to go tangent 63 equals opposite over adjacent. All right, so that means tangent 63 equals x over 10. Do you see how I made that substitution? All right, now I don't mind if you just go ahead and plug it straight in on your homework and don't rewrite it again. But it is helpful because you can just make sure again that you're plugging in the numbers in the right spot. All right, so now, just like we did in example 2, we can evaluate this. Tangent 63 in your calculators. Hit tangent 63, and what do you get? Tangent 63.
1.962.
All right, so we get 1.962. Remember, we go out 4 decimal places. Equals, but leave it in your calculator. Don't clear it out. Do you hear me? You went tangent 63. Don't clear it off your calculator. Just leave it. You'll know why in a second. All right, equals x over 10. All right, does anybody remember, now we're solving for x. Does anybody remember how I could solve for x in an equation like this? How could I get x by itself? You guys remember, this is going all the way back to solving equations. Could I subtract 10 and just get rid of it by subtracting it? Is that the opposite of division? I would multiply both sides by 10. All right? And when I multiply both sides by 10, now all I have left is the x, which was my goal. Whatever I do to one side, I do to the other. So now with your decimal, your long decimal still on your screen, now just hit times 10. Okay, this just gives you a slightly more accurate answer than if you were to round it in the middle of the problem. So now you have x is approximately 19.6261. But your instructions on your homework will say to round to the nearest tenth. So go ahead and do that. X is approximately what when you round it to the nearest tenth? No, tenth. Tenth is the first decimal place, so it's going to be 19.6. Okay? So what's it saying? It's saying that in a tangent situation, if the angle measure is 63 degrees, I can tell the length of this side without actually measuring it. Okay, so we can use trig ratios to find side lengths without actually physically measuring it. Do you think you could do one of these? All right, we've got to try one because you actually have 2 of these on your homework tonight. Okay, so let's say it's let me try to find another one so I don't have to make it up. Making up these problems is a little challenging. Okay, so here's your triangle. Let's do this. Forgive me if it's not perfect. All right, we gotta connect them down here. All right, so I've got Q, N, M, 20 degrees, X, and 48. All right? Okay, so go ahead and solve for X. Yeah, round to the nearest 10. What's my starting point? What's my starting point?
48.
Okay, no, not 48. I always start with the angle measure. Tangent of 20, okay? So I go tangent 20 equals, what's my ratio? What's my ratio for tangent? Opposite over hypotenuse. So which side is opposite? I'm sorry, yes, opposite over adjacent. So which side is opposite? X. No, look, 20 degrees. Which side is opposite 20? X. Okay. Now, which side is adjacent? 48. Okay. Now finish solving. So we start with the angle measure. We plug in opposite over adjacent. And now we solve the equation. We solve for X. Go ahead and finish. What's my next step? Multiply by 48. Okay. So we multiply that side by 48. And we multiply, oh, sorry, not yet. We need to find tangent of 20, right? Tangent of 20 is 0.36397. Okay, so since it's 0.36397, that rounds that to 3640. Okay, 0.3640 equals X over 48. Now I multiply both sides by 48. All right, don't forget to evaluate that tangent. Multiply the other side by 48 and times 48. 17.47. So that rounds to 17.5. All right, did anybody get 17.5? All right, that's really good. Okay, so it's going to be a step-by-step process. This is brand new, okay? The title of the lesson really doesn't hide the fact that this is a trigonometry type of concept, but this is a very, very basic concept of trig, okay? So when you get up into the upper level high school levels, they explore this like way beyond just your basic trig ratio, okay? So, but we do need to learn our acronyms. SOHCAHTOA, that's going to be foundational to you understanding these concepts. So we're going to recite them, we're going to learn it, we're going to practice, we're going to review. Your quiz tomorrow does not cover 9.5 and 9.6, okay? Or, I'm sorry, it does not cover 9.7, only 9.5 and 9.6. All right, that's everything you need to know.
You have a quiz tomorrow?